Okay, we're going to continue with 4.5a, going over U-substitution problems dealing with indefinite integrals. So 33, here we see this is a simple enough problem where we don't have to go through U-substitution. We can simply expand. So when we expand, we can just distribute the square root of y through, and we simply have something that we can use power rule for. So distribute the square root of y through, and when we multiply these two terms, we add bases. So 1 times 1 plus 1/2 is 3/2. So we simply go through power rule and bring up the fraction in the denominator and simplify all that we can. Okay, 47. We see that we have to go through U-substitution. We want to pick the u value here. This is the u value that is inside the cosine function, so we let the u value be 1 over theta. And if we look ahead, the derivative of 1 over theta will eventually turn into 1 over theta squared, which will allow us to cancel that out. But that may not be as apparent, but just know that if you're choosing between two terms, the inner function will be also one that will take precedence over one that is outside. So we let u equal 1 over theta. So we rewrite that as theta to -1 because we do want to find the derivative and we do want to apply power rule. So du over d theta, notice theta is now our independent variable. Okay, derivative, so bring down the -1, subtract 1 from the exponent, -1 theta to -2. Rewrite that as -1 over theta squared, cross multiply. D theta is equal to negative theta squared du. Okay, we start making our substitutions. 1 over theta squared does not get replaced, so we leave that there for now. Cosine of, we do have 1 over theta being u, times d theta gets replaced with negative theta squared du, which we found from here. Okay, so now we have almost everything in terms of u and du. The theta squared nicely cancels out, but we do have to keep track of this negative, so pull the negative out. Integral of cosine of u, remember the rule for the antiderivative rule for cosine is simply sine. So we keep the negative, so negative sine u plus c, and then replace u back in terms of theta. Okay, 51. Similar to practice problem that we did in class, so we want to rewrite this using parentheses. So tangent of x to the 4th times secant of x squared dx. If we let u be tangent x, then our derivative will cancel out the remaining terms here. Okay, solve for dx. dx is du over secant squared x. So we start making our substitutions. Tangent x gets replaced with u, so we get u to the 4th. Secant squared x times du over secant squared x. Secant squared cancels out, and now we have something clean that we can find the integral for. So u to the 5th over 5 plus c, so we get 1/5 tangent x to the 5th plus c. Okay, 53. Integral of cosecant squared over cotangent cubed. Let's rewrite this using parentheses. And now we want to identify the u value so that the derivative will cancel out the remaining term. Okay, so if we let u be cosecant, then the derivative will be cosecant cotangent, or sorry, negative cosecant cotangent, which will not cancel out the remaining term. But if we let the u value be cotangent x, then the derivative will be negative cosecant squared x, which will nicely cancel out this. So that's what we're going to make our decision on. U is cotangent x, du over dx is negative cosecant squared x. Cross multiply, solve for dx. dx will be du over negative cosecant squared x, and cotangent gets replaced with u, so u cubed. Cosecant squared nicely cancels out. Keep track of this negative, pull this in front. We want to apply power rule, but variable has to be in the numerator, so bring the u up to the top. Now we apply power rule, negative u to -2 over -2. Bring the u back down to the denominator. We want our final solution in terms of positive exponents. Okay, replace u back in terms of cotangent. So we can leave our solution in this form, or we can bring the cotangent back up as tangent squared. That's what the back of the book has, but this is perfectly acceptable. All right, 55. We don't have a rule for the integral of the cotangent squared x, so U-substitution does not work. However, we can rewrite integrand using trig identities. We know that 1 plus cotangent squared is cosecant squared, so so therefore cotangent squared is cosecant squared minus 1. So we rewrite this because we do have a rule for cosecant squared, which is negative cotangent of x, and negative 1 becomes negative x. So we have our indefinite integral here, our antiderivative here. Okay, 61. Find the equation for the function with the given derivative passing through the point. So we have our f prime being our function here at point 2, 0. So here are the steps. We want to find the indefinite integral to get up to f of x. So we have f prime. We want to get up to f of x, and we're going to come across a plus c. So now we're going to use the ordered pair to solve for c. Okay, and then once we have that, then we have our function. So we find the indefinite integral. So we do have to go through U-substitution, okay, or we could expand it out. It's not that big of a deal with squared here, but we can let the u value be 4x squared minus 10. Du dx is 8x. Solve for dx. Dx is du over 8x. We make our substitutions. 2x does not get replaced initially. The parentheses gets replaced with u, so we have u squared, and then dx gets replaced with du over 8x. The x is canceled out. The 2 over 8 reduced to be 1/4, so we have to keep track of that coefficient. Go through power rule. U squared becomes u cubed over 3, so we get 1/12, and u gets replaced with 4x squared minus 10 cubed plus c. So now we have our function that we can now we can plug in our ordered pair 2, 10 to find our c value. So here's our function, our family of functions with the plus c. 10 goes in for y, 2 goes in for x, and then we simplify, reduce, combine terms, and we get c is equal to c plus 18 is equal to 10, so c is equal to negative 8. So now we can replace our c in terms of a specific solution, in terms of with negative 8, so we can have a specific solution. These are change of variable problems where we go through U-substitution, but our variable does not cancel out, so we have to make an additional substitution. Okay, rewrite this using parentheses. U value is x plus 2. Du over dx is 1. Solve for dx. Dx equals du. And now we start making our substitutions. X does not get replaced, so we leave that alone. X plus 2 gets replaced with u, so we u to the left. Dx gets replaced with u. This is still standing, is still to be taken out. So the way we do that is we look at what's the relationship between u and x, which is u equals x plus 2. If we solve for x, x equals u minus 2. So now we can replace x in terms of u, which will allow us to continue with the problem. Okay, distribute the u to the 1/2 through. We want to get this ready so we can get this set up so we can apply power rule. Okay, so now we're ready to go with power rule. Variable is up in the numerator. Go through power rule. Okay, bring up the denominators, and then replace your u in terms of x. Okay, 65. The same way. We let the u value be 1 minus x after we rewrite it using rational exponents. So u is 1 minus x, du over dx is negative 1. Solve for dx, dx equals negative du, so we make our substitutions. Parentheses to the 1/2 becomes u to the 1/2, negative du. X squared does not get replaced initially, but we can solve for x using the relationship between u and x. So x equals 1 minus u. Okay, make our substitution. We have 1 minus u, quantity squared, times u to the 1/2 times negative du. So this takes a little bit more work because we have to expand and distribute the u to the 1/2 through. So that's what we did here. Distribute the u to the 1/2 through, and we keep track of this negative as well. So once we have all the terms separated, apply power rule. bring the denominators up to the top, bring the fractions up to the top, and then combine any terms that we can, and finally replace our x in terms, replace our u back in terms of x.